Find the slope equation and deflection equation for the given diagram.
This is the question of simply supported beam carrying point load as well as moment at point C. We are going to use Macaulay's method and we have to find out the bending moments of these loads at the section XX. So we will consider any section XX at a distance small x from this end A. So we will mention here the distance small x and here is the section XX. Now we will apply Macaulay's method. So how to write the formula? So formula is EI d square y by dx square. So this is the left hand side, and now on the right hand side we have to take the moment at the section XX. So first point load is 75 kilonewton. So when we apply the moment, that is force multiplied by the perpendicular distance. So here the perpendicular distance in between this 75 kilonewton and this section XX is given x. Now if I move the compass about the section XX in the direction of 75 kilonewton, then here is the direction, that is the clockwise direction, and we will use the positive sign. So how to write this bending moment? So 75 multiplied by x. So I will write here plus 75x. Now we will move to the next point load. Now if we observe from this first point load to the second point load, this part is known as the first part. So I will mention here this is the first part, and for this first part I will draw here one vertical line. Now we will move to the next point load. So the next point load is 300 kilonewton. Now for this 300 kilonewton up to the section XX we have to measure the distance. So how to measure this distance? So this whole distance is x and the distance AC is 4. So remaining distance is x minus 4. Now we have to move the compass at the section XX in the direction of 300 kilonewton. So it is in the anti-clockwise direction. So we will use negative sign. So for this negative sign, how to write the bending moment? So we will write here minus 300 into distance x minus 4. Now at the same point, this moment is acting, which is 150 kilonewton meter. So we have to write as it is because this is the formula for the bending moment, and moment at point C is mentioned 150 kilonewton meter. So we will write here as it is. Now what is the direction? So direction is clockwise direction, and for this clockwise direction we have to take the positive sign. So I will write here plus 150. Now we have to also consider the distance of this moment at point C and in between the section XX. So it is x minus 4, but this moment is given, so this distance must be equal to 1. So anything raised to 0 is equal to 1. So we know this rule, anything raised, that is any term raised to 0. That means if I write here 2 raised to 0, 1, 5 raised to 0, 1, in the same way x minus 4 raised to 0, 1. So anything raised to 0 is equal to 1. So this moment we have to take as it is, and we have to also mention the distance, but this distance should be equal to 1. So I will write here x minus 4 raised to 0. So this term is equal to 150 only. Now this is the formula by using Macaulay's method. Now if we observe this moment 150 and this 300 kilonewton is in the second part, because this is the point load 300 kilonewton and the next point load is 225 kilonewton. So all the points in between point C to B are in the second part. So I will write here, this is the second part. So this is the first part and this is the second part. Now we will move to the next step. So we have to take the integration on both the sides. So we will take the integration on both the sides. So EI dy by dx is equal to, now we will apply the formula integration of x raised to n is equal to x raised to n plus 1 by n plus 1. Now here x raised to 1, that means n is equal to 1. So I will write here 75. X, integration of x is x square by 2. Now we have to take the constant of integration in the first part only. So I will write here plus c1 because this is the first integration. So I will take plus c1. Now first part is getting completed. So we have to draw here one vertical line. Now we will move to the next. Now next x term is x minus 4 and bracket raised to 1. So again we will apply this rule. So I will write minus 300 as it is, x minus 4 square by 2, then plus, then 150 as it is. Now x minus 4 raised to 0, that means n is equal to 0. So how to write here? 0 plus 1 divided by 0 plus 1, that is x raised to 1 by 1. So I will write here multiplied by x minus 4 raised to 1 divided by 1. So this is the first integration. Now again we have to take the integration on both the sides. So EI y is equal to 75. Here x square. So 75 by 2 I will write here x square, that is n is equal to 2. So here x cube by 3 plus c1, it will become c1x. And we have to take the second constant of integration because this is the second time integration. So I will write here as a c2. And then we have to complete the first part. So remember, we have to take the constant of integration in the first part only. Now we will move to the next. So for the second part, minus 300 by 2. So that is minus 150. Now here 2, n is equal to 2. So I will write here x minus 4 cube by 3. Then here plus 150. X minus 4 raised to 1, that is n is equal to 1. So it will become x minus 4 square by 2. X minus 4 bracket square by 2. So here this is the second equation. Now if we observe this dy by dx, it will be our slope equation, and when y is there, then this is our deflection equation. So to find out the slope equation and deflection equation, we have to find out the unknown terms C1 and C2. Now if we observe, this is the simply supported beam. That means the deflection at the end points A and B, value of y is equal to 0. That means deflection at these points y is equal to 0 and y is equal to 0. And what about the value of x? So if we observe, the value of x starts from A. So at point A, x is equal to 0, and at point B, x is equal to, so here x will start from A and ends at B. So 4 plus 2, that is x is equal to 6. Now we have to apply these boundary conditions. If we observe the boundary condition at point A is in the first part. So if we observe this diagram at point A, if we apply these boundary conditions, we have to consider only first part, and point B is in the second part. So we have to consider all these two parts. So first we will take x is equal to 0, comma y is equal to 0. So this point A is in the first part, so we will consider only this part. So when we put x is equal to 0, y is equal to 0, then C2 will become 0. So we will get the value of C2, C2 is equal to 0. And now when we apply x is equal to 6, y is equal to 0, then we have to consider all these two parts because point B is in the second part. So we will put the values. So y is 0, this term will become 0, x is 6. So here 75 divided by 6 multiplied by 6 raised to 3 plus C1x, that is 6 C1, C2 value is 0 plus 0. So here the first part is getting completed. We will simplify this. Minus 150 by 3, that is minus 50, and x is 6, 6 minus 4, that is 2 raised to 3 multiplied by 2 cube. Here there is also we have to take plus 75. Now 6 minus 4, that is 2 raised to 2, that is multiplied by 2 square. So we have to calculate this and we will get the value of C1. We get the value of C1 is equal to minus 433.3. Now when we put the value of C1 and value of C2 in this equation, then we will get the deflection equation. And when we put the value of C1 in this equation which is in the form of dy by dx, then we will get the slope equation. So we have to write the deflection equation, that is we will put C1, that is minus 433.3x, and C2 is 0. So we will not mention this. So this is the deflection equation.